Hello, puppies and kittens. I have a tendency to be on social media and get into a lot of these ridiculous arguments where there are trolls all over, whether it's YouTube or Facebook or Twitter or what have you. And sometimes there'll be these arguments that are completely ridiculous, and I can handle the ones that deal with my area of, I'll say, special interest. But then there are some things when it gets too much into the weeds of genetics or paleoclimatology or what have you, that I would really like to hear how the people in the field deal with these particular questions. And we know that these are being posted by people of arguing for faith in bad faith, and so on. But just exposing the trolls, as it were. I happened across this one thread in a creationism Facebook site, wherein Moses Okalota said that there's not a single observation in real science or linguistics that we creationists dispute. That's why most of the founders of modern science were creationists, and why even today we have creationist nuclear and other physicists, chemists, geologists, paleontologists, geneticists, medical doctors, engineers, and biochemists and linguists. We certainly dispute the materialistic framework in history in which these observations are interpreted. That's a quote from Jonathan Sarfati, PhD. And Moses Okalota says, I couldn't agree more with Joe. Translation: creationists created science. We're not anti-science. All evidence lead to creation. Nothing was left to happenstance. We won't relent in telling people that truth, no matter our academic disciplines. Of course, there's no such thing as creation science in the sense that creationism doesn't do science. And creationists did not invent science. There are people who were creationists and have contributed to science, but creationism hasn't contributed anything. There's no theories. There's no model. There's no explanative power. There's no predictability. There's no way of making or falsifying a prediction. None of that. The entire application of science is completely lost on creationism. It's a non-science. It's anti-science, to be blunt. So I said in this comment thread that while they're pretending that they don't deny science, I pointed out you do deny genetics, especially phylogenies, and the fact that mutations are the ultimate source of new information in the genome. You also deny the decay rates of radioisotopes, and you deny several aspects of biology and geology that disprove a young Earth and a global flood. And that prompted some people to talk out of their arse about radiometric dating. Joel White says that radiometric dating is flawed based on how external radiation sources always corrupt assumed decay rates. Especially the longer the decay rate, the worse corruption is introduced. Plus, the scientific method Christians like Bacon developed always requires hypotheses to be tested by repeatable observations in real time. You can't repeat if an isotope takes billions of years to decay unless you have billions of years of scientific observation data points with a stopwatch and be able to repeat it. You proved science is strictly forbidden in atheist cult beliefs, as Einstein and every scientist complains about. NIST tries to shield their radiometric dating calibration experiments from external source corruption with 7 tons of lead, and it's still not enough. So I thought, well, since I don't do this, but I know someone who does, why don't I address this ridiculous thread with an expert? Jonathan Baker, remind my audience what you do for a living.
Glad to be back. I'm a geochemist who studies paleoclimatology, and a big part of studying and reconstructing past climates is to figure out how old the things are. If you don't know how old it is, then it doesn't really do you much good. So we employ a number of techniques using uranium or even carbon isotopes to date materials and look at proxies for past climates. Okay, let's take that in pieces. So first, this idea that external radiation sources can corrupt assumed decay rates. And potentially what he's referring to here is that let's start with 238 uranium. That's a good one. How do you figure out the decay rate? It's not like you can take that material and measure how much 238 uranium you have today, and then tomorrow measure it again and see how much is lost, or maybe 10 years or 30 years from now, see how much is lost. Rather, what you look for is the specific activity of radioactive decay. How many particles are decaying per second or per minute at any given time as a proportion of the mass that you have. So if you know, if you have exactly 1 gram of a radioactive isotope, and you could measure how many alpha particles or beta particles or gamma rays are coming off of that material, then using Avogadro's number to convert that 1 gram to the number of moles, the number of atoms, and then the number of alpha particles will be a proportion of that number of atoms. Then proportionally how many decays you have per per mass of the atom. And that's all they're looking for. They take a highly purified piece of uranium. By mass spectrometry, we can figure out how much of that is 238 or 235. And if you go back to, I would say a good recent, not recent, a good paper that measured this is by Jaffe et al. 1971. It's easy to find, Jaffey. Where they had a setup. They took that mass of uranium. They were very careful with how they plated it on the measurements capsule, and then they had an alpha particle detector with very high efficiency, took an ultra pure sample. They knew very well from mass spectrometry whether it had any impurities in it. So there was a lot of control in this lab experiment. And they set it up to count alpha particles spitting off. So they knew the mass, and this way, by monitoring, they knew how many particles were coming off per minute. And they did this until they got at least 1 million alpha particles counted, right? And it actually doesn't take that long. It's about 3 or 4 days of monitoring with the mass that they had. And they were able to count, about 200 decays per second with the mass they had. And then they did that again and again and again and again with the different subsamples to test the variability in there. Okay, so if that's your setup, if you're counting alpha particles that are produced anytime 238 uranium decays into 234, you have a potential source of error if there are any other alpha particles in the room that are caught by the monitor but didn't come from your sample, right? So that is important. You need to shield external radiation so it doesn't corrupt the measured decay rates. With alpha particles and alpha decay, that's really easy to do. You can block alpha particles with a piece of paper, with your skin. It's quite easy. The biggest challenge, perhaps, is to have a clean air supply. And so they did that. They used a specialized lab air supply of argon and methane mix, if I recall, to ensure that they don't have things like dust floating through the air. Dust may have a piece of thorium attached to it that could spit off an alpha particles and mess with your measurements. So in this case, they were very careful to constrain the atmosphere, shield it from external radiation, which is very easy to do. And they measured it over a sufficiently long time period to get good counting statistics. And that's it. And they weren't the only ones to do this. Over the 20th century, we got, like a half dozen or more long-term experiments that looked at this decay rate. And they all fall roughly within error of each other, within statistical error of each other. There are some differences, but it's on the order of 1%. So our assumed half-life of 238 uranium has changed by about 1 or 2% since from 1935 to 1971. If that external radiation were such a major source of error, we wouldn't see that level of agreement across decades of experiments in different labs, different technology, different setups, and everything else. But we do. We see a lot of corroboration in that. I've provided to you the source where you can look at how those data compare across the 20th century, and they're as aligned with each other as you could expect given the advances in technology over that same time period. So he's referring at the end here to NIST shielding their radiometric dating calibration experiments from external source corruption with 7 tons of lead. Why would you need lead to shield it? Well, alpha particles don't penetrate just about anything. You can shield them very easily, but gamma rays and beta particles can, right? So if you are measuring something like iodine 129, which is the link that he got this from, it was describing their setup to measure the half-life of iodine 129. And because this is a beta decay process, you need something like lead shielding to keep out more external radiation. So, but it is he says it's still not enough. I mean, that's just nonsense. It's obviously enough given the level of corroboration here. But the other thing that he didn't mention, probably doesn't know about, is that not every alpha particle, not every beta particle are the same. They all have different energies. And for any given isotope, the alpha particles emitted from, say, 238 uranium will have a different energy from those emitted from other isotopes of uranium, let alone thorium and anything else that decays by alpha decay. So by looking not only at the number of alpha particles, but the energy levels of those alpha particles, it's quite easy, as long as you have enough counts in the statistics, it's very easy to distinguish between background or other contaminant radiation versus your sample of uranium or thorium that you're trying to measure. Okay. So yeah, if you're measuring beta decay, you need more shielding, but it's the same principle. You do it with a number of samples with this method. Some other team over here, a different part of the world, they do the same thing with their own lab, their own method, different levels of background radiation. You report it all and how you made any corrections, if you did, for external sources. And that's it. So there are, from IUPAC, several reviews where they do meta reviews of all of those experiments and make recommendations for the most probable half-life. And yeah, if you want to be ultra precise, then you could nitpick about this error here and there, but they all overlap with an uncertainty. We're highly confident that, that external radiation sources aren't throwing this off in a way that would, make us mistakenly think the Earth is 4.5 billion years old when actually it's only 2 billion years or a million years or less. Like that's not the level of error that we're looking at. This is like 4.5 billion versus 4.4 billion.
Very good. So you do radioisotopic dating, and so you have firsthand experience in all of this. So how would you address some of the key comments that you saw in here?
These are a little different, and the focus seemed to be on, in a nutshell, that we can't measure these decay rates because they're so slow, or we can't scientifically corroborate the decay rates. And I mean, ostensibly, that's an understandable misunderstanding. Like I can see how that would be a little strange. And maybe by analogy, I would first give this example. You're flying down the freeway, as I'm sure you do, across the plains of Texas, and you get pulled over, and an officer says, do you realize I got you on the radar going 100 miles per hour? And your first response is like, well, that can't be right. There's no way that you've been tracking me for the last hour over the last 100 miles to show and prove that I was traveling 100 miles per hour. And in reality, it didn't do that. The radar got you going about this far over a number of milliseconds, right? Does that mean that you can't accurately measure that velocity of 100 miles per hour if you didn't monitor it for the entire 100 miles, right? So I think that's, in a nutshell, what they're getting at here is that, a decay rate of, say, 238 uranium, which is approximately 4.5 billion years, can't accurately or scientifically be measured, confirmed, corroborated, because we don't have that sort of observation time. What we do have is, like, number one, we can measure that in real time. We don't need 4.5 billion years to figure out a decay rate, in the same sense that, in milliseconds, we can get the velocity of fast moving objects. The other thing is, there are a number of ways by which we can try and corroborate this, or test the assumption that those decay rates were constant over the period that we assumed they were, right?
Okay. So, I mean, I responded to this person. I said, when he made these allegations, I said, why is it then that when multiple methods are tried where different isotopes are tested, they consistently corroborate each other when nothing whatsoever ever backs up your mythical folklore? And he responded, they don't. You have to average the errors, and the longer your isotope takes to decay, the wider the external inferences causes error and corrupts the assumed decay rates. To confirm a 4 billion year old sample scientifically would require having a 4 billion year old stopwatch with a 4 billion years of carefully collected records, never breaking the chain of custody. So everything you worship, from your cult of anti-science, blind faith, and mythological fantasy and hopes of and dreams you'll never be able to verify, You're literally claiming a broken clock is accurate regardless of how many times you check it. Because this person has to project as much of themselves onto me as possible. So I'm the one that believes on faith. I'm the one that believes something that can't be scientifically verified. I'm the one in a cult, according to this guy, because everything he's guilty of, he's arguing against himself, and he's just put me in his mirror. And then he continues on with the rest of that, and then you religiously ignore. Well, we'll get to that next comment in a moment. How would you deal with the first paragraph of this?
Um, well, for one, it's quite a standard, and that wouldn't pass anywhere else. I'd really be interested to hear that play out in a courtroom. Like, this doesn't count as evidence because you didn't have perfect monitoring of the entire crime with all of these other records and observations. Uh, and it's just not how it works. And it certainly wouldn't work if you use that same standard to discuss history, or say the transmission of texts, religious or not, through time. Like this, we have to deal with pieces of evidence, and we have to use the scientific method to put that all together. I mean, just to reconstruct ancient pieces of literature like Gilgamesh uh, requires a bit of scientific method, and it requires creative ways to test plausible hypotheses or falsify them to figure out the most likely, original structure of that text. So here, what we do, if you want to test that assumption that this decay rate was accurately measured and that's what it was over this long course of time, then the best way is to use multiple isotopic systems, right? If you've got several isotopes, each with their own decay rate, then each of those independently could give you an estimate of the age of the mineral. And so they should give the same result as long as all other assumptions are met. And you're right, consistently, and more often than not, for sure, they corroborate each other, and they can tell us that, whether or not that those assumptions were met, and give us extremely high confidence that, nothing in nature changed that compromised that decay rates and made it different from what we have now. I mean, there are very, very few conditions in nature that could affect the nuclear stability and therefore the rate of decay for any given isotope. And there are certainly none that could exist in Earth's surface systems, including the crust and mantle, right? So you'd have to have a complete shift in the fundamental laws of atomic physics and the subatomic particle interactions, quantum mechanics, and the basic forces of nature. So it's a very safe assumption to make, and it is highly corroborated when we do have multiple isotopic systems looking at each other. It's very standard. If you're using uranium, thorium, or uranium lead dating, you don't just measure one isotope, you measure several of them, all the different decay chains, and use that to come up with the best age estimate. Right? You don't simply assume that everything stayed as a perfectly closed system, nothing was gained or lost. And even though we call them assumptions, we don't just assume and leave it at that, right? We test it by measuring all the different parts of the chemistry. Or even, if you got a mineral like this, you take the age at the rim, take the age in the middle, take the age at the very core of it. And if those are all the same, that can help test your assumption that everything was in line. So that's it's simply false to say that they don't. By and large, they do. And when they don't, we understand pretty well why they don't. Um, the idea that the longer it takes to decay, the wider that external interference. I mean, you can look at the error bars in those papers, and they're extremely small. And so, yeah, that is kind of true. Like, the slower the decay rate, the bigger the error bar, but they're so small. This is like the limit of radiometric dating and precision. It's no longer such a limit at the mass spectrometry steps, but rather a limit of our errors on what the decay rate is, and that's pretty good. It means we can tell the age of something with not within a percent error, but within a per mil error in either direction, right? Or less than a per mil. So it's very nice. Besides that, like, do you really need a stopwatch and something in monitoring over 4 billion years to do this? I mean, no, you really don't. You make hypotheses based on the physical principles. If that's correct, these are the data we should find. and you test, are those the data we find or not? Right. And what you're
Indeed.
doing is measuring the geochemistry of the mineral to test whether it meets the expectations based on the principles of radioactive decay.
And that brings back to where I mentioned that nothing ever corroborates his young Earth. There's no peer-reviewed study. There's nothing he can point to for anybody's hypothesis that was resolved with this result that was predicted by creationism, because creationism isn't a science. It doesn't make predictions. It certainly isn't testable. It's not potentially falsifiable. And it meets exactly none of the criteria required of a scientific theory.
When you do
Go ahead.
those claims, like they say, well, we've got this material and we carbon dated it, and it's not from the Cretaceous, it dates to 30,000 years old. Uh, every single time I look at that and I go back to their table of results, you'll find that their dates are all over the place, like orders of magnitude from each other in terms of the isotopic ratios. And it's just, you can tell right away, like this is not internally consistent. This is actually falsifies what you meant to argue from it. But I don't think they catch that because they don't routinely use the scientific method to investigate this.
But what they do is they pretend that they're the scientists and that I'm the religious one.
Mhm.
And of course they do this with everybody. They do this juxtaposition where science is based on faith, and is based on evidence, and all of that. They're trying to argue against themselves, pretending that I am them.
So one thing about that though, because it really bothers me when people do this, and and the reason is that I mean, this is the last thing you should be arguing for, that there's some sort of systematic bias here that's undermining your ability to interpret the evidence, right? And they're pitting this against like themselves and you, the one on blind faith, not paying attention to the evidence. And he's using this phrase over and over again, this atheism, cultism, atheism, church, or academic church, or whatever it may be. And it's just simply contrary to observation. Like I would say, I've got at least half my colleagues are probably religious in one sense or another, and they range. I mean, I have atheist colleagues, I have agnostic colleagues, I've got plenty of Christian colleagues, even Muslim, Buddhist, and Hindu colleagues, and they all agree on the principles of radiometric dating. We work in the same labs. We use it to answer the same types of research questions. And when you have people of that diversity in, say, philosophical or religious ideals all coming together and agreeing on, there aren't many things where you can find a good level of agreement in that diversity of demographics, but you do find it here because scientifically this is internally consistent.
Well, the same incapacitated intellectual also said that only atheists believe in evolution.
Mhm.
So, that to give you what the kind of caliber of what we're talking about, he then went on and said, and then you religiously ignored the irrefutable fact that there are parent isotopes still decaying on this planet, and others that have less than 4 billion years of total life, falsifying the hypothesis that anything has a longer decay rate than the youngest parent isotope available. You ignore all posts and are only forced to repeat your cultic dogma. Thanks again for scientifically confirming why science is strictly forbidden in atheist cultism.
Yeah, notice they didn't point out which isotopes presumably those are. Any intro geochemistry textbook will talk about the difference between long-lived isotopes and short-lived isotopes, and why we don't find the short-lived isotopes, except for the ones that are produced, say, in supernova, and therefore are continuously created throughout the universe history, right? Those, yeah, they can be manufactured naturally, and so we might detect them today, even though they would decay away within millions of years. Um, but we know the difference between, like, only the ones that are produced in supernovae can we detect short-lived isotopes. The rest they just are not found in nature. So this was one of the things early on in geochemistry that confirmed our suspicions, or our better estimates of the age of the solar system and the universe itself. The fact that we don't find those short-lived isotopes. So he's taken this fact in favor of our known history of the universe and pretended that it somehow contradicts it.
Okay, thank you. And then he goes on to say very young parent isotopes still exist on the planet, as well as further falsifying old parent isotope decay rate assumptions. Uranium 235, for example, has a theoretical half life of 700 million years, giving it a theoretical total life of 1.1 billion years. So, if the planet were 4 billion years old, based on the U 238 half life assumptions, there would be no nuclear fission reactors today. Since there are very many nuclear fission reactors today, the planet cannot be as old as anti scientists, meaning scientists, claim that it is.
Well, at least it's set up like a coherent argument with, if then that, and that's good. But what is this? Like, I didn't realize you have to go this far back to the basics. But if something has a half life of 700 million years, like 235 uranium does, uh, that means after 700 million years, half of it has decayed away, and after 1400 million years, 25% of it would have decayed away. So we should still have 25% of the original after 1.4 billion years. So how can it have a 1.1 billion year total life, whatever that means? It's not a term that we'd use. Um, when after 1.1 billion years, there should be more than a third of the original left.
Again, as I said, this person is obviously just doing copy pasta for arguments that he himself does not understand,
Without
but it
doing
makes
a
him sound
refill
smart.
sanity check on it too. Like it doesn't take much math. Intro earth science students could do this math without a problem. So I don't know.
So, so I said to him that I've interviewed a number of paleoclimatologists, people who personally do radioisotopic dating, and they wish you had a clue. I could give you one, but it seems you don't want to know what is true. You would rather make believe something else instead. And he said, no, you didn't. You interviewed academics who couldn't get a real job outside of your academic church cult. That's why you're strictly forbidden to address any of the actual facts and appeal to your fellow church cult members as authorities. So, is it that you can't get a real job? Or is it that you're an authority? It's not that the facts weigh out, it's because it's whatever you say because you say so.
Yeah, whether or not I could get a real job outside, I mean, that might be half true. I'm not sure. I'll give him credit on that one. But no, this is where I want to be. I like being in academia and research. So it's also partly by choice. Still, I think I don't know. It's really silly to me. And I've worked in a number of universities. Some are private and even religious founded universities. Others are public universities in multiple countries. And I don't know what this academic church cult is supposed to be. It's certainly not a haven of atheism. We, it's just, it's not what it is. There's the academic freedom here. So, we've, like I said, I've got colleagues of all flavors of faith and non-faith. And this perception is just, it has to be completely rooted in ignorance to shout out to as a way of dismissing, whatever others might say. Like I only trust the ones who've basically shut themselves out of academia by taking a stand with things that are already falsified. You know.
So I think we're done with that one. I did want to ask you about one more that you when you looked at that thread, you said you were interested in another one
Mhm.
where somebody said they found a dinosaur about 5 years ago that had living tissue.
Hmm.
It carbon farted back to thousands of years, not millions of years. I read the Science News Daily.
Mm.
Or maybe
That's
he says, I read the Science News Daily. So he's not talking about the Science News Daily. Maybe he is talking about that magazine. I can't tell.
it might have been the medium that reported some article about that, or maybe not. Regardless, what he's referring to as living tissue is certainly not living tissue, and it's a big misunderstanding and a little bit understandable. Like for there are many reports, about soft tissue and other preservation of organics in very very old bones. I mean, you've spoken a lot about this, right? But what we find in things like dinosaur bones is not living tissue. It's not soft tissue. It is the degraded remnants that's been bound to other mineral parts, and in that sense has survived to the modern day. It's not original DNA. It's not original proteins or collagen or anything like that. And what's interesting here is that you will find a number of younger organizations who have spent the money to take old samples like that and send it off to a lab like they would any other bone, a bone of, say, I don't know, maybe a mammoth from 30,000 years ago. You want to carbon date it, so you send it off, and the first thing you would want to do is separate the parts so that we can date the minerals, bone mineral matter separately from the collagen, separately from this, because they all have different susceptibilities to decay and contamination. And so they send it to the lab without telling them this is a Cretaceous age dinosaur bone. And so the lab's just going to apply the same chemical treatments that you would to a standard bone to separate out collagen. But at the end result, because there's no collagen in the bones, what you end up with is not collagen. It may have carbon in it, and therefore it's going to yield a non-zero carbon age. I mean, a non-infinite radiocarbon age. And that's just how the system works.
The way I understood it, and I have interviewed a number of people who were doing research on the soft parts, including Mary Schweitzer, the one who first discovered the soft tissue. An interesting story about her was that before she began, when she began working in this paleo lab, she was a young Earth creationist, and now she's an old Earth evolutionist. So, and she's the one that everybody, all these young Earth creationists are citing as their source for all their information.
Mm-hmm.
Now, part of what you said was actually inaccurate from the paleontologists that I've spoken to. That they said that there's a way that collagen can survive extremely long and even be rejuvenated chemically,
Mm-hmm.
so that collagen is extremely durable. So if there is any true original material, that would be it, because of this bizarre chemical property that it has. But in other cases, things like, it's exactly what you were talking about. When they say that they found blood cells, for example, that fossilization replaces the lighter items with heavier minerals or whatever, except that vertebrate blood is based on iron, and so what you get is heme.
Mm-hmm.
It's iron, the iron molecule with constituent parts. It is as you put it, the degraded blood molecule. This is what's left. This is the fossilized deterioration of blood. There's nothing. Whatever they have found that has been movable has been microscopic and has to be demineralized and has to go through like weeks of acid bath to do so, and only occurs in the insulated areas of large bones that are buried deep and all of that.
Yeah.
So what they found is extenuating circumstances by which these extreme things are actually possible.
And what you end up with, like the mass that you end up with, that is that degraded remnant of those organic molecules, it's so small in comparison to the total bone mass. It's certainly nothing that would contain enough of the original carbon to be datable, even if it were young enough to be dated. And so what you're actually dating, any carbon that ends up going into the mass spec and giving you that radiocarbon age, is going to be a mixture of sources. And likely none of that is from the original organics, or a very, very microscopic amount. A bulk of it will be from minerals and other contaminants that have latched onto that since, or that were part of the lab process in preparation. So in other words, it has no relevance to the age of the organism itself. It tells you a lot more about the diagenetic history of the organism, what happened to it geochemically since it was buried.
Thank you for that explanation, because I like to understand these things. I don't want to just sit here and argue, and certainly if I don't understand, if somebody makes an argument and I'm unfamiliar with it, I want to talk to the people who are in the know, who studied this, to explain what is this really. And so I very much appreciate you coming on my show again in order to do that.
Well, it's my pleasure. I'm glad to be back and talk with y'all.